Assalamualaikum warahmatullahi wabarakatuh and a very good day. I hope you are doing well during this pandemic situation. My name is Amira Atika binti Suhairi and today I will present to you my FYP1 project presentation under the title of Experimental Study of Biofluid Lubrication Characteristic for Artificial Joint under the supervision of Mr. Muhammad Mazwan bin Mahad, and I am presenting to Sir Khairul Imran bin Saidan and IRTS Dr. Muhammad Ali bin Ahmad. There is 5 main content in my project presentation. Firstly, the introduction to the lubrication of artificial joints. Second, the problem statement, objective and scope. Third, the literature review. Fourth, the research methodology. And finally, the expected result. Have you ever wondered what is lubrication for artificial joint?
Clinical studies show intra-articular injection of HA, which is a primary component of the synovial fluid in healthy joints, can help reduce pain and increase joint function in patients with osteoarthritis.
Some joints on human body for artificial joints such as shoulder,
binding of HA to nerve cells reduces their sensitivity and ability to respond to pain stimuli.
Also known as knee prosthesis. Have you ever wondered what is the issue with the lubrication for artificial joint? Normal joint will have synovial fluid to help them to glide on each other, while artificial joint cannot create their own lubrication. Movement of the knee joint requires an effective lubrication mechanism. Many people understand that articular cartilage in human body is the one that cause the bone to glide on easily on each other, but more important than that is actually the joint fluid. So imagine a car engine. Like a car engine has oil, so the two metal don't rub on each other, and once the oil get low, the metal will start producing heat and producing reaction when they are metal on metal. And then the engine is going to freeze and you could totally destroy the engine. The human body is the same way. The artificial joint giving a better hold to human, but without the lubrication to it, it still will disrupt over time and another surgery is needed. Synthetic synovial fluid is reported to serve this function. Synovial fluid supplementation is seen to enhance the life of total knee replacement joints. Development of effective synthetic synovial fluid is proposed in worldwide research. This is the reason why this experiment focusing on developing synthetic synovial fluid using biolubrication for artificial joints. From the start of my presentation, have you ever wondered is the research topic is still relevant to be done with the keyword of synthetic synovial fluid and lubrication for artificial joint? I found 3,508 articles, papers, and journals related to the topic. The lowest number of publication is on 2011 for 114 papers and journals, while the highest publication is on 2021 for 271 publications. For the 10 years of publication, this trend is increasing and show that the topic is still relevant to be done as a research. So that is the reason why I continue my project to do the research on this topic. Over the years, many researchers have made research on biofluid lubrication using vegetable oil. Yet, they still can't determine which vegetable oil can be used as synthetic synovial fluid that can mimic the characteristic of synovial fluid. Yet, the gap that we have here will use for this project to investigate the various types of vegetable oils such as castor oil, olive oil, and sunflower oil to see whether they can mimic the same characteristic as synovial fluid or not. So there comes the objective of this project to see whether the oil and additive that we add using castor oil, sunflower oil, olive oil with the additive of 1% hyaluronic acid, either this kind of sample can have a friction coefficient as low as 0.03 and wear it as small as we can to be used as a synthetic synovial fluid for the artificial joint. This is the scope and limitation for my experiment. Firstly, I use the lubricating condition using pin on this tribometer, focusing on this kind of experiment because I want to see the disc that I use using a PLA and stainless steel can give the best mimic situation of the knee joint. And next, I choose the time for 30 minutes or 1800 seconds, an activity of working with speed of 360 rpm. And next, the weight of human body is 50, 70 and 90. The reason I choose this weight because human in Malaysia for multiracial weight is mean at 43 until 93 kilogram. And lastly, the effect of parameter that I use is wear rate and friction coefficient because this is the most effect that we needed if we need to do a lubrication for a knee prosthesis. The literature review for my project is first from Dr. Prakasan Dr. K.K. Saju. Synovial fluid supplementation is seen to enhance the life of total knee replacement joint from the article of review of the tribological characteristic of synovial fluid. These words can be seen as the importance of the synthetic synovial fluid for the artificial joint. Next, the alternative lubrication for synovial fluid is important for long-term functionality of joint and imparting effective boundary lubrication from A. Galandakova et al. From the article characteristic of synovial fluid required for optimization of lubrication fluid for biotribological experiment, as these have seen the importance of synthetic synovial fluid for the lubrication boundary, giving the best effectiveness for long-term functionality. And the last one is from M. Mariam et al. Biotribology, which involve the lubricative properties of certain components in human biology, is one of the main driving forces for exploring different biological or bio-inspired fluid or mixture with superior lubrication properties from the journal Exploring the Lubrication Mechanism of Synovial Fluid for Joint Longevity, a perspective. From all the literature review that I have done, I agree, and all the researchers are agree that biolubricant should be discovered as one of the lubrication application for the synthetic synovial fluid. This is the research methodology for my experiment. After the literature review, the next step is the pre-experiment, preparing for the sample and the disc and pin. For the preparing of the sample, I use 3 samples from castor oil, sunflower oil and olive oil with the additive of hyaluronic acid. And after the process of mixing the additive and the base, I will do the viscosity measurement using the viscometer. For the disc and pin, I have choose thermoplastic polymer PLA for the disc and using pin from stainless steel. The 3D printing for the disc will be done and then we'll continue for the oil and the disc to be used in the tribological test in tribometer. The load that I choose with the speed will be put into the tribometer test to obtain the coefficient of friction for the objective 1 and obtain the wear rates for the objective 2. And after get the coefficient of friction and wear rates, I will compare them with the previous result of studies I've made. If the result with the previous study is compatible and the experiment will be. This is the pre-experiment preparation for my project. We will boil 3 types of oil: sunflower oil, castor oil, and olive oil with the hyaluronic acid. We will mix all the 3 types of oil with 1% of hyaluronic acid, and the main focus for this pre-experiment preparation is to get the best viscosity to be run in the pin on this tribometer. Next, the disc. I have done the 3D printing of PLA disc using SolidWorks software. And next, the smoothing process of this surface using tetrahydrophane. Tetrahydrophane is used for the PLA disc. After a while reviewing all the papers and journal, I expect a result as friction coefficient as low as 0.03 and wear rates lower than 0.008 mm cube per Newton meter for my sample of oil and hyaluronic acid. From the previous study, sunflower oil, castor oil, and olive oil have a lower friction coefficient. I hope with addition of additive of hyaluronic acid, the sample will get a lower friction coefficient as expected. That's all from me. If you have any inquiries, please contact me via email or phone number stated. Thank you.